In this video lesson, we'll be learning about a new way to write linear functions called recursive form. This is going to be entry number 37 in your math notebook, so make sure to label your input and output correctly. Let's start with an example of a linear function. In the following tree pattern, a constant increase in the stage number corresponds to a constant increase in the number of trees at that stage. Because there is a constant rate of change in that you're adding or subtracting the same amount, or in other words, that you have the same slope every time, this pattern is considered linear and also known as an arithmetic sequence. The easiest way to write an equation for this function would be in slope-intercept form, since we know that there is a constant m slope value, and we would just need to move one step backwards to find the initial y-intercept value. To write our equation in function notation, we would use f of n instead of y and n instead of x to represent the stage number. For our slope, our constant rate would be the 2 trees per one stage, so 2 over 1 or 2. And then instead of b, we would replace that with our y-intercept, which we found by going backwards to the stage 0 and finding that initial starting point with just one tree. This equation form, slope-intercept f of n equals to 2n plus 1, is in a category of writing functions called closed or explicit form. The closed or explicit form of a function is when a function is written as just one expression after your f of n or output variable. Writing a function in closed form allows you to evaluate any input to get any output without having to know any of the previous outputs leading up to it. Today you'll be learning a new way of writing functions called recursive form. In recursive form, your function is written as multiple expressions after the f of x or f of n variable. Similar to how you would write a piecewise function, a recursive form consists of your output variable f of x or f of n equal to a curly bracket in which you'll have multiple expressions that make up different parts of that function. Recursive form describes how to get a new output based on previous outputs. So it relies on what answer you already had for a previous output in order to get the next new output. The name recursive comes from the definition repeating, so you can think of a recursive form function as always referring back to itself or repeating back onto itself. Let's take a look at how to write recursive form for the same pattern that we saw earlier. The first step in writing recursive form is identifying something called the base case. The base case is your starting output when you have an input of 1 or an input of 0. While most recursive functions are written starting with the input of 0, you could begin at 1 instead if you wanted to start your function later on to have that function only exist from the x or input value of 1 and onwards. In our linear pattern example, our table of values starts with an n input of 1, so we'll choose 1 to be our starting input, and so we'd have a starting output f of 1 being 3. The next step you'll need to do is to find the relationship between the current output and the previous output. To do this, we'll want to choose two input-output relationships to look at. So I'm taking a look at f of 2 giving us an output of 5 and f of 3 giving an output of 7. The difference between the output of 5 and the output of 7 is adding 2. So the pattern to get to the current output 7 from the previous output 5 is to add 2. The last step in writing a function in recursive form is to follow piecewise function notation. Since our output variable is f of n, we'll want to start out having f of n equals to a curly bracket, and then we want to start with our base case, which is the fact that if we start off with an n value input value of 1, we would have an output of 3, so we would write 3 if n equals 1. And then for the second line of our curly bracket, we'll want to write the rule that we found to get from one output to another. The code or the key phrase to mean previous output is f parentheses n minus 1, because that means that if you subtracted 1 from your input value, which means you're going backwards to your previous input value, that would be the code to go back to your previous output. And then after that, we want to put the rule that we found in step 2, which is that you had to add 2 to get to the next output. So we would put add 2 after f of n minus 1. And finally, at the very end, we want to write if n greater than 1 because we want to show that this is the rule that applies for any input values that are larger than 1. Basically, any input values after the starting input. Let's practice our knowledge of closed form and recursive form ways of writing functions. Take a minute to try to write the closed form and recursive form of the linear function shown in the table. The simplest way to write the closed form function is in slope-intercept form. Instead of y, we want to use the function notation f of x or f of n, depending on what variable you use for your inputs. You could either use x or n. F of x equals to 5 times x plus 3. 5 because that is our rate of change or constant slope each time, and 3 because our y-intercept is at 0, 3 given in the table. For the recursive form of this function, we want to start with our f of x or f of n variable being equal to a curly bracket. Then in the curly bracket, our first line should be about the base case. Our base case from this table of values could be the input value of 0 because our table starts at the input of 0. So we will want to talk about the output we'd have if we have an input of 0, and that output that we'd have is 3. So for our base case, we would write 3 if x or n is equal to 0. In the line underneath that, we would want to use that key phrase, meaning previous output, f parentheses x minus 1 or f parentheses n minus 1, depending on the variable you use. That phrase means referring to the previous output, and we want to figure out what that relationship from output to output is. And if you just pick two output values next to each other to look at, to get from 3 to 8, you would have to add 5. So that means we want to put plus 5 after that key phrase f of x minus 1. And so for our total phrase, we would have f of x minus 1 plus 5 if the x values are greater than 0. So showing that every x value greater than 0, after that we would follow the rule of adding 5 to the previous output. The last skill we want to learn today is being able to evaluate a function in recursive form. In this example, we want to find the value of f of 5 given the recursive form f of x equals to the curly bracket -2, our base case if x equals to 1, and then the f of x minus 1, meaning every previous output subtracting 3 if x is greater than 0. To reach the output value of f of 5, we would actually have to create a table of values in order to reach all the way up until the 5th output. So starting with our base case, we can write into our table of values that at the input value of 1, we'd have an output value of -2, and then from there, apply that rule that's given to us right after the key phrase f of x minus 1. The rule in this case is to subtract 3 from every previous output to get to the next output. So if we want to get from 1, -2 to the next output for 2, we would have to subtract 3 from -2, which gives us -5. Then to get to the next output, we have to subtract 3 again to get us to -8 when our input is 3. Then we'd have to subtract 3 again to get from -8 to -11 when our input is 4. And finally, to get to when our input is 5, we would have to subtract 3 from -11 to get us the output of -14. So that tells us that f of 5 is equal to -14. Another way of figuring out the output value when we're given an input value into a recursive form is by converting from recursive form into closed form. Remember that closed forms allow you to just plug in the input directly and get an output value without having to rely on previous outputs. So if you can convert between recursive and closed form, you can just plug in the value into the closed form. So how do we get closed form from recursive form? Well, you can look at the rule. If your rule is adding or subtracting a certain number from the previous outputs, that means you have a constant rate of change, and that would be your slope number. Then you want to make sure that in your table of values or your base case, you're starting from the x value of 0 to get your y-intercept. If you don't have an x value of 0, then you would have to create an x value of 0 by going backwards from wherever your first starting base case is. Since our starting base case is x being 1, we'd have to go backwards to reach 0, and so instead of subtracting 3, we would have to add 3 to negative 2 to move backwards to when our x input is 0. Negative 2 plus 3 gives us positive 1, so that means at an input of 0, our output would be positive 1, and our y-intercept would be positive 1. So our closed form function would be f of x equals negative 3x plus 1. Now we could just substitute 5 into the x input to get f of 5 equals to negative 3 times 5 plus 1, which is the same as negative 3 times 5 is negative 15 plus 1, which is the same as negative 14. So we end up with negative 14 as our output in both cases where we created a table of values to evaluate the recursive form and when we converted it into closed form and plugged in 5.